Monty.
All right, thanks. Hi, everybody. I'm Andrew Brandt. I'm the Director of Threat Research at Symantec. Thank you all for coming. Just before we get started on the talk, I wanted to let you all know I'm a very interactive kind of person, and I would encourage you all, if you have questions, to just go ahead and raise your hand during the talk. I don't mind being interrupted. Anybody who asks a question can come up and take a prize. I've got some pumpkin spice caramels and some CDs and magnets and stuff. Nothing fancy, but it's cool, and I just want you guys to be interactive and be participating. So we're going to talk a little bit about some of the work I've been doing with Trickbot the last couple of months. I do a weekly internal WebEx at Symantec teaching the sales engineers and a bunch of other people how to do malware analysis and research into these kinds of things. And so I'm going to talk a little bit about my tools and the things I use in my lab to do research, and then I'm going to show you what we were able to find. So this is my rack in the lab in Draper, Utah. It consists of a few different tools. Not all of them are listed on this sheet, but the main ones that I'm going to be talking about today are security analytics and the SSL visibility appliance. SSL visibility is sort of the key tool here, which is it's a standalone man-in-the-middle SSL decryption box. All you have to do is generate certs on the device, put those certs into the cert store on your whatever machine you want to inspect, and then anything that is sent over TLS to that machine, the box will re-sign the certs and send the decrypted traffic out to basically any device that you want if you want to capture it. So I'm capturing it with security analytics, and security analytics is a sort of enterprise-grade packet capture tool that can sort of capture the entire network's traffic all at once. And while it does that, it's collecting a bunch of metadata about every packet and putting that metadata into a database which you can then browse through a nice UI. So let's talk a little bit about the history. So now, almost 3 years ago, I did a presentation about basically what are the sort of current trends in bots, and I did a section about a bot called Dyer. And this was what we were able to discover about Dyer 3 years ago, is that it was doing everything over TLS, and a lot of the communications, once you decrypted the TLS, were in plain text or were fairly easy to sort of read and understand. And we were even able to kind of parse by inference the command structure that was used for Dyer. And that was fun. And then when I sort of saw Trickbot's traffic for the first time earlier this year, I thought, oh, wow, Dyer is back. How weird, because it looked exactly the same. And then I read the blog by Jerome Segura from Malwarebytes, where he's basically said that Trickbot is a rewritten version of Dyer. It all made sense. So in the end, what we started to see was a very familiar set of commands. These are the commands here, and I'm sorry it's kind of hard to read because it's such a light screen. But basically, all of this stuff that was being done by Dyer is essentially being done by Trickbot. It's a little bit more streamlined. It's a little bit easier to read. And they're doing basically the same stunts that they were doing 3 years ago with Dyer. They're doing TLS, but not necessarily over 443. They're using static user agent strings in the malware to do all the command and control stuff. So it becomes very easy to identify that traffic using a couple of different characteristics. So what I started doing was recording a bunch of the Trickbot traffic that we were decrypting, and then kind of looking for ways to basically abstract it into simpler ways of understanding what it's doing. And I came up with this list of the commands that were being issued. And what you can see, these are all the HTTPS requests that have been decrypted, but you can see that most of them are GET requests. There's a couple that are posts, and that there are some, basically this pattern is followed over and over again ad infinitum as long as the bot is infected on the machine. So here's how we, interpreted some of these things. All right, so it does these GET requests to sort of provide information up to the server. The information is in the URI string, and when the server has received it, it sends back /1/, which is basically, okay, I've got it. Like I said, it's always TLS encrypted, but it isn't necessarily 443. So with Trickbot, we've seen some conventional like 443 traffic, but also 447, 449, and other weird ports that you wouldn't expect. So if you see, SSL over 449, that's almost certainly Trickbot doing command and control. The other thing that we're discovering is that in many cases, but not in all cases, the server is returning weird error codes. It could possibly be the fact that the server's overloaded or is getting weird responses, or they're in the middle of updating it at the time when we're doing our beaconing. But I think that in some cases, the server is actually intentionally trying to mislead by giving 404 errors. So in some cases, and it's kind of predictable with certain kinds of commands, that the server will respond with a 404. Now, I don't know for certain because I don't have a Trickbot command and control server and all their source code to be able to analyze it. But the reality is that it is very suspicious that that's the case. Most of the exfil that you see with Trickbot is done through the GET requests, but when it's big amounts of data, they use a post data request to send that stuff up to the server. And then for every instance of Trickbot's components, I don't know if you know this, but basically the bot pulls down a bunch of DLLs and then invokes different functions from each DLL. Each of those instances of a different component has its own common service host.exe that it's injecting into and using for its purposes. So what you see on an infected endpoint when it's running Trickbot is usually a parent service host.exe that's the main service that runs the bot, and then each of the components is a child process of that service host, which is another service host. So there might be like 7 or 8 service hosts underneath. It's sort of like the user level of the machine. Some other sort of things that I want to mention about the behavior is that unlike Dyer, Trickbot does not use the stun protocol to do its determination of what the public-facing IP address is on the network. Instead, they're using a bunch of different public services like ICANN has IP to figure out what their public-facing IP address is. And this is important because when it's profiling the infected machine, it's trying to, it needs to know that public-facing IP so that then command and control can operate effectively. It does all kinds of credentials and data scraping. Each of the components that is pulled down can scrape different types of data, but then they also can use different components to do attacks as well. So we've seen that they've already created a module that uses Eternal Blue to spread laterally within a network. And the screenshot that I'm showing here is just some slices from security analytics where we saw that it was basically running through an entire series of subnets trying to do Eternal Blue. And when we looked up the IP address range, it belongs to the US Department of Defense. So I just hope that they don't arrest me on the way back into the country. So it is also distinctive in that instead of using a run key or the startup folder in Windows, that it uses the scheduled tasks mechanism within Windows to create a scheduled task, and that task runs the main executable that installs Trickbot and does the initial injection about every 15 minutes on the box. So you could kill all the service hosts, and that will temporarily stop it, but then 15 minutes later, the main executable will run again. It will start up that initial injector, and then that thing will just go and check to see that it's all installed and just start running again. So there's really, it's kind of difficult for a lot of people to get rid of it. All right, so let's look at some of the C2 traffic that I was able to record. So this is this year's version of what I showed you that was the 2014 presentation. Like I said, almost all of the commands that it's using are GET requests over HTTPS. The command structure basically follows this pattern that you see up here. And let me jump back for one slide because I want to show you something. Let's see, it's actually 3 slides. So this is the folder where the software is running from. And what you can see is that there's a bunch of executables in there. These are different versions of Trickbot that have installed themselves. There's also these files called client ID, group tag, lastver, and config.conf. All of those files are basically created when the file is initially installed on the box. Group tag is a 5 to 6 character short tag that basically identifies the campaign that's being used to spread Trickbot. And so when you see the URI strings, you see that all of the URIs that are being requested by that particular version of Trickbot will follow the same group tag. They always have the group tag in the beginning. They also generates a unique identifier for the infected machine, and it sticks the identifier inside that client ID file, and then that is also passed in the URI during the request. So jumping forward, let's get back over here. So what we see is that you've got the group tag up here as the first thing within the URI. There's the name of the machine that it's on, and I've just got those obfuscated for obvious reasons. There's a sort of the NT code mechanism for showing which version of Windows is running. In this case, it says W629200, that's Windows 8. Client ID is hidden, but it's basically 32 bytes. It kind of looks like an MD5 hash. Then the command is a set of both a number and a name of a module. And each of the modules is named as a unique name. The command is basically the number, and we've done some inferences on sort of what those commands are based on observed behavior and the network traffic that we recorded. And then there are some subcommands or feedback data that gets sent back as part of that. So here's how we inferred some of these commands. So the initial contact, the first time it was requested, is a /0/SPK is the first command that you see. And that's just a check-in. And all that's passed up to the machine is just a GET request, and it comes back with a 1. The next thing you see is a 5, which is to download some payloads. And then those payloads are downloaded, and as it's doing the payload downloading, it's profiling the machine, sending information back, requesting more payloads based on what that profile says. Those payloads will then run, and they will send back data individually as well. There's also some other commands, like just sort of like a TB phone home is number 25. 63 is a issue a command to this particular payload. 64 is used, at least as far as we know, exclusively by the Eternal Glue exploit, which is called worm DLL. And then there's a component called mail client, which is able to send out more sort of weaponized documents in email using the email addresses that it has scraped off of the machine. And when it does that, it uses send to send that information out. There's also a couple of other commands, /10 and /23, which I just haven't really puzzled through yet, but we'll get there. So some of the information that it's sending is this profiling data, and it sends this all actually in plain text. So once you've decrypted the traffic, it's easy to just see when this thing does its system info post, it sends back a pretty detailed profile, all the installed applications and services, and a lot of details about the hardware that the machine is running. And there's a couple of reasons why they might be doing this. Obviously, they want to know about the environment that they're in. They want to know about the user accounts that are on this machine. But they also want to know, is it running in a sandbox? Is it running a VM? And so actually, in this case, it was running. We ran this sample in one of our sandboxes called Malware Analysis Appliance. And it is essentially a kind of souped up virtual box running within a server. But we've masked the signatures of the CPU IDs and other things as a way of kind of evading sandbox detection. So it reports back that it was running a Core i7 in this case. And it just sends all of this stuff as like a giant post. After that, it then starts downloading configuration data. And it does this sort of on a regular basis. It cycles through it basically every 15 minutes and pulls down configuration data for 3 different kinds of different banking attacks that it will use, and it sort of tailors those attacks to specific banks and the login information that they store, and also how their web pages work. So some pretty interesting stuff, and it's worth noting down these URLs because all of this configuration data is sent down in sort of an encrypted mode, and the decryption tool that you can use to read it is on this URL right here, this Trickbot decode. So that's user on Twitter named Hasherazad has a lot of tools in her GitHub, and one of them is this sort of Trickbot configuration decoder, and it's really useful. So even though you don't have access to the box itself, if you're doing this SSL decryption and recording this traffic in something like security analytics, you can just pull these configuration files off the wire and decode them and figure out not only what banks are they targeting, but what the command and control server is that's waiting to sort of listen to the extraction of the credentials. And you can block those IPs. That's useful because the division that I work with at Symantec classifies URLs and IP addresses as malicious, and then we use our proxies that are out in big enterprise environments to block connections to those. So in theory, our customers are kind of protected. At least this bot cannot exfiltrate the credentials to these IP addresses because we know about them and we're blocking them. The other thing that I wanted to mention is that but just before I got here, another researcher contacted me and said, hey, you should really read my research. I've been doing a lot of work on Trickbot. And he wrote this really fascinating blog post that's about the specific injection methods that Trickbot is using, which I'm not going to go into detail with here. But his post is here. And I'd highly recommend you read it because it is a very interesting thing. It explains what the different types of injections that are being used to sort of steal the credentials are. And so this one is the dinge configuration. Then there's one that's called singe. And it is slightly different than the other configuration. And what I discovered yesterday is that the two researchers from F5 were here, and they were talking about doing decrypting of traffic and data. And they explained to me what this NH was. So the way that it works is that there's basically data that's being sent up to the server, the command and control server, that kind of lets them know which bank specifically the credentials that are being sent are from. And each of these weird-looking URLs is basically just a unique identifier for each particular bank. And they do change over time, but you see that there's the targeted bank, and then there's its unique identifier here. There's also capability to sort of create a 404 page for the bank, but none of them are being used right now. Finally, there's some other config data. One's called dpost. The other one is mailconf. Dpost is used by the main Trojan to do credential theft. Mailconf is used to do theft of mail credentials as well as email addresses in Outlook and other mail clients. And it's used to send mail from the infected machine on occasion. Both of these are also decryptable using the tool that was created by Hasherazad, so really useful tool. And all you can see here is that there's some binary data, but there's some IP addresses in there as well, things that we want to block, and that's good. All right. So when the thing does its periodic check-in, normally it gets a /1/, and then the bot goes away for 60 seconds to 3 minutes, and then it goes and checks in again. And periodically, one of those things will not be /1/. It will be a string of data that's a little bit longer, and it's very easy to see that in tools. And so this is the artifact of a particular download that was requested for a machine called Victim. And it says, go to this IP address and get 397.png. And that turns out to be an executable. And so in a similar vein, we have another one here where it basically sends a command to a different box, and the command is share DLL control infect. And when it did that, so this is the request where the data that came back was this. The next thing that happened is, did I lose my mic? The next thing that happens is that share DLL 64 is downloaded, and you can see that it's a binary data file. It doesn't get decrypted until it ends up on the infected endpoint, in which point Trickbot then turns it into a real DLL, and it can go off and do its thing. And then you can see here that the next thing that happened was it downloaded yet a second executable that was another PNG file, but that was a PE file, so it was masquerading as an image. All right, so that's cool, and it's nice to be able to see the traffic, and it's nice to be able to block those IPs. we have this really interesting tool that we created internally called Billiard Room, which is a sort of data correlation tool that allows us to cross-reference file hashes, IP addresses, domain names, and some whois records. And in addition to showing like where things are talking to, where they're coming from, there's some there's a little bit of directionality to it as well. So that if a certain IP address is hosting a lot of malware, we'll see a lot of arrows coming out of it pointing to different other machines, or we'll see if it's a command and control server, a lot of arrows pointing to it, meaning that there's malware that is talking to it. And so I'll show you, and we integrate the Blue Coat data from the division that I work in, the Symantec threat data from Star Labs and the security response team, and a bunch of third-party outside services as well, just so that we can understand better what's going on. So the first time I did a billiard room query on a single Trickbot sample, that's what the map looked like after 5 minutes of going through the database and querying it. Now, it's really hard to read. But the idea, so this is the sample that I started with. And from this sample, we were able to determine, well, A, there's a whole bunch of other samples that are also talking to these same domains. The blue blobs are the domains that are being communicated with. Some of them are the command and control servers. Some of those are the IP address things. I zoomed it in a little bit so it was easier to read. Hopefully that's slightly easier. So these ones that are along this edge, you can see are all the different IP address services that they're using to query the for information to get the IP of the public-facing IP of whatever network they're on. And they're using basically every service that's out there that they can find. And they don't really care which one they use. And it kind of varies from day to day which one they're going to use. So they might use multiple, but usually they just use a single one. And if they can't use it, then they'll jump to the next one. But you can see that there's a lot of samples that will talk to this one and this one and this one and this one. Likewise, these are the command and control servers here, the IP addresses. And you can see that a lot of the samples are going to talk to this one and maybe one other. And they move around a lot. And that, the command and control server is dictated by a config file that's in the initial Trojan. And then that Trojan will periodically update that config file and get new C2 servers as they're going offline or new ones come online. Likewise, I did some queries on some of the IPs that are used for the sort of credential stealing or the destination of the exfiltration of credentials. In this case, so here's the dpost config file, and dpost is the sort of the main sort of destination for all the exfiltrated credentials. When I did the billiard room on it, so this is it's 194.87.102.39. It's this one here. So this domain, and it's really faint. There's a line here that points to this whois address, info@may10invest.com. And it turns out that that domain has been used to register a few other domains, including cloud.place and fxprime.com and may10invest.com, obviously, and ddoslab.com and ddoslab.ru and ddos-lab.ru, et cetera. Yeah, so I was actually kind of curious to figure out, like, why would you want to invest in May 10th? What's May 10th? I had no idea what that date, the significance of that date. So I Googled it, and it turns out that May 10th is a holiday celebrating the Confederates of the Civil War in the United States. So the people who wanted to defend slavery and who are now emboldened by the Russians and in their efforts to basically subvert democracy in the United States. I guess that's why you'd want to invest in May 10th. But there are almost too many leads to follow with this. There's a million threads in these, and you saw how big that network was with Trickbot. So let me show you a few of the network IOCs, and then if we have a few minutes, what's our time like?
It's nearly finished.
Okay. If we have a minute, I will do my demo. So some of the network IOCs, if you're not doing SSL decryption, the certificates are always like alphabet salad, so they're just a bunch of junk. You'll see that they're invalid certificates. you're doing the TLS just to IPv4 addresses. There's never a domain name associated with Trickbot. It's all IP addresses. It's doing requests to services that are doing these public IP address checking. So if you see a lot of lookups of icanhasip.com or all these other ones, these services are not generally used by consumers unless they're highly technical folks like people in this room. But that aside, if you see a bunch of things on your network that are checking those, it's worth probably looking at the machines that are doing those checks. And then if you see a bunch of PNG files coming from random websites, going to those same machines that are doing those IP lookups, if you're able to inspect the contents of those PNG files and you see that MZ header, that's a pretty strong indicator that you've got Trickbot. Now, if you are man-in-the-middling the data and you can see things like the headers and the server responses, one of the sort of characteristics of both Dyer and of Trickbot is that they had a consistent user agent string. And in this case, the user agent string is that it's running Windows 10 Chrome 57. So if your users' machines are not running Windows 10 or you don't have Chrome as part of your install base and it's not Chrome 57, then you know that that's a lie. And that's a pretty strong indicator, again, that you've got Trickbot doing stuff. Now, that's not to say it will always do that. And I suspect after they probably watch this presentation, the Trickbot authors may change this up a little bit. The reality is that for a long time, this has been a pretty easy way to figure out that they're lying, and but they might change that. All right, so we have time for a demo?
2 minutes.
We have 2 minutes. I'll skip the demo because it's only just to show you that we can do the extraction and security analytics, and then you can just decrypt it with the Hasherazade tool. So I'll just open it up to questions since there have been no